Dear lovely viewers, welcome back to my channel. Let's quickly profile a solution to the problem on the board together. So I have this nice system of Diophantine equations. A squared equal to B plus 1A3, which is our equation 1. B squared equal to A plus 1A3, which is our equation 2. Now we have to find the integer solutions of A and B where A is not equal to B. So that shall be our guide. A is not equal to B. The first thing we shall do is to subtract equation 2 from equation 1. So that will give us A squared minus B squared equal to B minus A, 1A3 minus 1A3. That will subtract out to be 0. The next thing again, I'll take everything to the left equal to 0. So I'm then going to be having A squared minus B squared plus A minus B equal to 0. Because if negative A crosses the equality sign, becomes positive. If B crosses the equality sign as well, becomes negative. Now we are all used to difference of two squares, which is a very famous algebraic identity. So A squared minus B squared can be written as A minus B in one parenthesis, multiply A plus B in another parenthesis, plus A minus B, let me also put this in parenthesis, equal to 0. And since A minus B is common to these two guys and this guy here, I shall factor it out. So I'm going to be having A minus B, put this in parentheses. If I use A minus B to divide into A minus B multiply A plus B is left. If I use A minus B to divide A minus B, I will have plus 1. Everything equal to 0. Now from the zero product property, it implies that A minus B equal to 0 or A plus B plus 1 equal to 0. Now, if A minus B is equal to 0, that means that A is equal to B. So we are going to reject this solution. Then we are left with A plus B plus 1 equal to 0. So A plus B plus 1 equal to 0. So if I take 1 to this other side, then have A plus B equal to negative 1. I will call this one our equation 3. Then the next thing I shall do again, having subtracted equation 2 from 1, is to also add equations 1 and 2 together. So if I do so, on the left side, we are going to be having A squared plus B squared. On the right side, I'm going to be having A plus B. Then 183 plus 183, that will give us 366. Now from equation 3, A plus B equal to negative 1. So I'm then going to be having A squared plus B squared equal to negative 1 plus 366. Now negative 1 plus 366, that will give us 365. So I can then say that A squared plus B squared equal to 365, which is our equation 4. Then again, I shall also go and look at our algebra toolbox, the perfect square trinomial. If we have A plus B whole squared, if I expand this, I'm going to be having A squared plus B squared plus 2AB. This is called the perfect square trinomial. If I decide to isolate A squared plus B squared, I'm then going to be having A squared plus B squared equal to A plus B whole squared minus 2AB. Then I can even call this equation number 5 for clarity. Now I will substitute equation 5 or infuse equation 5 into equation 4. So equation 5 is A squared plus B squared equal to A plus B whole squared minus 2AB. And in equation 4 on the left side we have A squared plus B squared. Then I will now write a plus b whole squared minus 2ab equal to 365. Now from equation 3, a plus b is equal to -1. So -1 squared minus 2ab equal to 365. -1 squared is 1. So this one will give us 1 minus 2ab equal to 365. So if I subtract 1 from both sides, I'll be having -2ab equal to, okay, if I remove 1 from 365, I will get 364. Now, if I divide both sides by -2, I'll then be having ab equal to 364 divided by 2. That will give us 182. And that's going to be negative. So I shall call this equation 6. Now, equations 3 and 6, I will solve it simultaneously. So I will take this part off. But I'm not going to do so by solving a quadratic equation. One of the problems I solved involving a Diophantine equation, one of our new subscribers raised a concern, and he hinted me that I should explain something. So I want to take this opportunity to do justice to that. So I have a plus b equal to -1. This is our equation 3. Then I have ab equal to -182, which is our equation 6. Like I said, I wouldn't want to solve this simultaneously using quadratic formula. Rather, I want to make do with another vital algebraic identity or formula. I know that a minus b whole squared is also a perfect square trinomial. It's going to give us a squared plus b squared minus 2ab. Now from equation 5, we can see here clearly that a squared plus b squared is a plus b whole squared minus 2ab. So I can then write a minus b whole squared equal to a plus b whole squared minus 2ab minus 2ab. So we are going to be having a minus b whole squared equal to a plus b whole squared minus 4ab. So our dear subscriber, this is how we actually got that formula. So if I take the square root on both sides, a minus b would then be plus or minus square root of a plus b whole squared minus 4ab. The reason why I find this method very flexible is that I already have a plus b. Then this formula here will help me get a minus b. Then I solve a simple simultaneous equation. Our homecoming is guaranteed. So therefore, a minus b, that will be plus or minus. A plus b is equal to -1. So a plus b whole squared, that becomes 1, -1 squared. Then we have minus 4ab, and ab is -182. So I'll write plus because of plus, okay, plus because minus multiply minus is plus. So I'll then be having 4 multiply 182. Okay, I think I should redo this for the sake of our audience in high school, because showing your procedures is very vital. So let me plug in the substituted values. So therefore, a minus b will then be plus or minus a plus b whole squared, and a plus b is -1. That will be -1 whole squared. Then minus 4ab minus 4 multiply ab from equation 6 is -182. Okay, I think it's better. So a minus b will then be plus or minus the square root. -1 square is 1. Minus 4 multiply minus 183. That's going to be 728. So therefore, a minus b equal to plus or minus the square root of 729. That's 1 plus 728. And that's going to give us 27. So I can then write, hence, a minus b equal to plus or minus 27. I can name this equation 7. Okay, I think I should take this up. So it's on the borderline. Okay. Okay. So to write this equation 7, a minus b equal to plus or minus 27. So our equation 7. Then I already have a plus b, which is equal to negative 1 from equation 3. Then I also have a minus b, which is plus or minus 27. Then I will say case 1. This case 1 is going to be the positive value of a minus b. I will write a plus b equal to negative 1, this equation 3. Then a minus b, I'm taking the positive value equals to 27. I will call this equation 7 star. So if I add equations 3 and 7 star, a plus a is 2a, b minus b is 0, then negative 1 plus 27, that will be 26. If I divide both sides by 2, a will be 26 divided by 2, which is 13. Then from equation 3, b is going to be negative 1 minus a. That will be negative 1 minus 13. Negative 1 minus negative 1, that's going to give us negative 14. In coordinate geometry or Euclidean geometry format, the first set of solutions, a comma b, can be written as 13 comma negative 14. So this is the first set of solutions. Then I will then for case 2. Case 2, we are then going to consider the negative value of a minus b. So this is the very last lab. We are considering the negative values of a minus b. Then I'll then have a plus b remains negative 1, equation 3. Then a minus b will then be negative 27, equation 7 double star. So if we also add these two equations together, b will subtract out, 2a will be negative 1 added to negative 27, that will be negative 28. If I also divide both sides by 2, that will be negative 28 over 2, which will give us negative 14. So the value of a is negative 14. Then from equation 3, b is equal to negative 1 minus a. So therefore, the value of our b will then be negative 1 minus 14. Minus is plus, that will be negative 1 plus 14, which will give us 13. So our second set of solution, a comma b, is going to be negative 14 comma 13. So guys, this is the end of this solution. Please give this video a thumbs up. Don't forget to share with your learning friends and colleagues. And please do well to subscribe to our channel and turn on the post notification so that you wouldn't miss out in our upcoming videos. See you next time and stay blessed.